Hi, I'm Kasha from Young Monks. Is coding required for Internet of Things? Is Python used for IoT? What software to use for IoT? In this video, we will answer all these questions related to Internet of Things. We will discuss their dependency on programming languages and other critical fields. The complexity of Internet of Things programming language depends on specific project and one's background in programming language. In a rapidly evolving landscape of IoT app development, programming languages serve as the backbone, enabling developers to synchronize a multitude of interconnected devices. Whether through Python, JavaScript, C, or Swift, these IoT programming languages form the landscape through which IoT apps communicate and operate, defining the interconnected nature of these innovative applications. Within the realm of IoT programming, microcontrollers and embedded systems like Raspberry Pi harness the power of popular programming languages like C and assembly, delving into the intricacies of low-level programming. Meanwhile, higher-level computer programming languages like Python and JavaScript pave the way for scalable and versatile IoT development, facilitating projects across various platforms and devices, including iOS and Linux-based systems. The rise of frameworks like Node.js have transformed IoT application development, allowing programmers to harness processing power effectively. With IoT devices proliferating gateways and backend solutions, often reliant on Java Virtual Machine, that is JVM, and PHP compilers, establish an ecosystem where data analysis, real-time operations, and scalability seamlessly depend on these frameworks and their processing capabilities. Debugging intricacies often greet beginners embarking on IoT projects, but machine learning and automation aid programmers in crafting robust solutions. APIs play a pivotal role in bridging the gap between systems, while compatibility and portability considerations underscore the importance of well-crafted IoT applications. The programming languages like C, Python, and JavaScript play a huge role in IoT. IoT programming is the art of orchestrating these interconnected systems. It involves leveraging microcontrollers, the backbone of the intelligent devices like Raspberry Pi and Arduino, programmed using languages such as Python, JavaScript, and C. These languages serve as the linguistic bridge, enabling developers to inspire devices with functionality and intelligence. Underpinning the IoT landscape is the choice of operating systems where Linux stands tall due to its adaptability and openness. Its role in enabling scalable development, robust backend infrastructures, and streamlined data analysis cannot be overstated. Meanwhile, frameworks like Node.js power the real-time responsiveness demanded by IoT systems, ensuring immediate interactions across diverse platforms like iOS and Android. IoT programming delves deep into software development, demanding an understanding of scripting, debugging, and scalability. Automation becomes key, orchestrating an ecosystem where devices communicate seamlessly through gateways and APIs, ensuring compatibility across platforms to create adaptable and evolving systems like respond intelligently. The search for the best programming language is ongoing. Python shines for its versatility, allowing for rapid prototyping and seamless integration. Meanwhile, C's low-level capabilities make it indispensable for embedded systems, and JavaScript, with its frameworks, enriches web-based IoT applications, enhancing their interactivity. IoT programming isn't just about coding, it's a fusion of creativity and technical acumen. It involves bridging hardware, firmware, actuators, and high-performance computing. It's about creating an open source ecosystem that thrives on collaboration, catering to both seasoned programmers and curious beginners. Now let us look at some challenges in IoT programming. Adapting code bases for devices with varied architectures, operating system, and capabilities poses challenges in creating universally applicable software. Ensuring code efficiency on devices with limited resources without compromising functionality is a constant challenge. Implementing robust security measures like encryption and access control to avert vulnerabilities in codebase. Overcoming issues arising from diverse protocols for seamless device communication is crucial. Efficiently managing and processing real-time data streams while maintaining accuracy is a challenge. Managing unreliable or intermittent network connections to ensure consistent data transmission reliability. Creating secure and reliable mechanism for remote firmware updates and software patches in IoT devices is critical. Balancing functionality and power consumption to prolong battery life in energy-constrained devices is a persistent challenge. Designing a structure capable of accommodating a growing number of devices without compromising performance is essential. Effectively processing and analyzing mass volumes of data from IoT devices in real time to derive actionable insights is demanding. Ensuring seamless communication among devices from various manufacturers with different capabilities and protocol is challenging. Developing systems that can gracefully handle failures or disruptions in network connectivity or device malfunctions. Optimizing computing processes at the edge to reduce latency and reliance on cloud services poses technical challenges. Managing firmware and software updates throughout the device's lifecycle, especially in remote or inaccessible locations. Ensuring adherence to evolving data privacy regulations and standards while handling sensitive IoT generated data. Addressing these challenges in IoT programming requires a comprehensive understanding of hardware limitations, security best practices, efficient coding techniques, and adaptive approaches to accommodate the evolving IoT landscape. It also necessitates collaboration among programmers, hardware engineers, and other stakeholders to develop robust solutions that drive the potential of IoT technology forward. Now, let us look at some advantages of IoT programming. Innovation and efficiency enables innovation by connecting devices, enhancing productivity, and streamlining processes. Enhanced connectivity. It facilitates seamless communication among devices, enabling data exchange and collaboration. Data insights and analytics harnesses IoT-generated data for informed decision-making and predictive analytics, shaping strategies across industries. Improved quality of life elevates living standards through advancements in healthcare, smart cities, and resource management. Now, let us have a brief look at the disadvantages of IoT programming. Security vulnerabilities. Increased connectivity introduces potential cybersecurity risks, leading to data breaches and privacy concerns. Interoperability challenges. Integration issues arise due to diverse devices, protocols, and standards, hindering seamless communication. Scalability and management complexity. Managing a growing number of devices and scaling systems demands efficient management of solutions. Data overload and privacy concerns. Coping with vast amounts of IoT generated data and ensuring secure data handling pose significant challenges. Now, let's look at some of the applications of IoT programming. Use IoT devices like Raspberry Pi, Arduino, or microcontrollers programmed in Python, JavaScript, or C to control home appliances, lights, and thermostats via smartphones. It can be in both iOS or Android. Develop IoT systems using low-level programming language for embedded systems and microcontrollers to enable real-time monitoring of machines, actuators, and sensors for manufacturing processes. Utilize gateways for data analysis and integration with backend systems. Create IoT applications using sensors, actuators programmed in C or Python on devices like Raspberry Pi to collect data on air quality, temperature, and humidity for analysis on Linux-based systems. Perform data analysis and implement automation for response mechanisms. Develop IoT solutions using low-level programming for embedded systems for medical devices and gateways to securely transmit data. Utilize high-performance computing power for data analysis and apply machine learning algorithms for predictive healthcare applications. Implement IoT systems using microcontrollers like Arduino or Raspberry Pi programmed in Python or C to collect data on soil moisture, temperature, and crop health. Use web development frameworks for visualization and scalability in monitoring and controlling agricultural processes. Develop IoT applications using sensors and actuators programmed in C or Python on embedded systems to collect real-time traffic data. Use backend systems for data analysis and apply automation to optimize traffic flow. Create IoT solutions utilizing microcontrollers and sensors programmed in C or Python to monitor energy consumption. Use frameworks for data analysis and scalability to optimize energy usage and implement automation for efficient energy management. Implement IoT systems using microcontrollers or Raspberry Pi programmed in Python or JavaScript for inventory management and customer interaction. Utilize backend systems for data analysis, scalability, and integration with web applications. The choice of best language for IoT depends on various factors, including the specific requirement of your IoT project, the hardware you are working with, your team's expertise, and other considerations. However, several programming languages are commonly used in IoT development. Widely used, efficient, and offers low-level control over hardware. Many IoT devices have resource constraints, and C and C++ can be more lightweight compared to higher-level languages. Development may be more time-consuming compared to higher-level languages. Known for its simple syntax and readability, Python has a large ecosystem of libraries and frameworks, making development faster. It's a great choice for prototyping and development of higher-level applications in IoT. May not be as efficient as C programming, C++ for resource-constrained devices. Object-oriented platform independence allows Java's application to run on various devices. Java is suitable for building complex, distributed systems in IoT. Can be resource-intensive for small devices. JavaScript, especially with Node.js, is used for server-side development in IoT. It's good for handling asynchronous tasks and building web-based IoT applications. For client-side development, this interpreted language can be combined with HTML and CSS. May not be as suitable for resource-constrained devices. Known for its simplicity, efficiency, and fast compilation, Go is suitable for building scalable and concurrent IoT applications. May have a steeper learning curve for developers unfamiliar with the language. Offers memory safety without sacrificing performance, making it suitable for resource-constrained devices. Rust is gaining popularity in embedded systems and IoT. Learning curve as Rust introduces ownership and borrowing concepts for memory safety. Lightweight and designed for embedded systems, Lua is often used for scripting in IoT devices. Limited compared to general-purpose languages, but suitable for specific use cases. The choice often involves trade-offs between development speed, the resource efficiency, and the specific requirements of the IoT project. It's not uncommon for IoT projects to use a combination of languages, with lower-level languages for device, firmware, and higher-level languages for cloud-based services or application development. So that's all for this video. See you in the next one. Thank you for watching.